So, let's go through this. Okay. Alright, so here is a blank unit circle. Unit circle, or even the word unit means, does anybody know what unit means? It's 1. So unit circle means it has something that is 1. What do you think is 1? Purple? Who said purple? Or did I hear purple? The radius is 1. So we're going to go through this entire thing with the radius of 1, and then we can start to make some really totally cool, awesome discoveries. Okay? So if the radius is 1, what is the starting position point right here going to be?
0.
Comma?
1. 0.
Huh?
0. Okay, you lost me.
Okay, I'm right here. I'm totally lost too now. I lost all faith in math. Okay, thank you, person that said it right for the first time. What is it? It's 1, 0. So this is starting position. So starting position is how many degrees?
0.
Has 0 degrees, which is also 0 radians. Also, this is related to if we take a full cycle. So how many degrees is a full cycle? Which is also how many radians? 2 pi. Try not to make this hard. I'm going to go through and do all the quadrantals real quick. What are quadrantals? Thank you. Everything has multiples of 90 degrees. That was on our notes last time. Okay, so what's the point that's up here? 0, 1. It is 90 degrees, and it is pi over 2 radians. The left side, what is that point? Negative 1, 0. How many degrees? 180. How many radians? Pi. I seriously think that too. Like, you need to be able to see everything here. I'm so sorry. Do you go like to the movie theater and like, hey, can you zoom in? Sometimes there's words.
She has a point.
Sometimes there's words. So Zoe does not go to see like international films whatsoever, where we have to read what they're saying. Anyway, let's talk about the unit circle and not some of these eyes who probably should be sitting closer. Alright, this bottom one. 0, negative 1. How many degrees is that? 270. What's my radians? Three pi over 2. Okay. I want to talk about this first guy right here. In the first quadrant, this is going to be 30 degrees, and this is going to be pi over 6. I'm going to do some drawing. I'm going to do it on the back side, so I'm not cluttering up my unit circle. You can either participate or just watch. Okay? So, on my unit circle, maybe I can zoom in for this. This is 30 degrees of the one I'm just doing. So I'm talking about this guy right here. So if I were to drop down a perpendicular right here, I would get the exact same triangle that I'm drawing. So this is 30 degrees, and the radius is 1. So how many degrees is this part right here? 60. Is there anything special about this triangle? What, does anybody remember the ratios for 30, 60, 90?
Square root of 3.
2x, x root 3, like that. And this is where 30 is. Because across from the 30 is the shortest side. Across from the 30 is the shortest side. Across from the 30 is the shortest side. We're good? Okay. So now, if this is 1, I'm actually dividing this all by 2x, technically. I'm dividing everything by 2x. So what does this side become? I'm going to use 1/2. What does this side become? Root 3 over 2. So this coordinate point right here on my unit circle, I'm going to get to that in just a second, will be how far over in the x's? It will be root 3 over 2, and how high in the y's? 1/2. So let's go ahead and go do that. So this is going to be root 3 over 2 and 1/2. I'm writing in marker so you can see better, but the only problem with that is it's a little bit thicker when I write it down, so it doesn't come across very clear. It's a double-edged sword there. Let's talk about this next one, which is going to be 45 degrees, also known as pi over 4. Okay? We'll do the same exact thing. I'm going to draw like the same triangle. I'll draw it in this corner over here. I'm going to draw the same triangle, but this one is going to be a what special triangle? What's the proportion for that? X. Okay, I got it. You see what you're doing. Okay, x root 2x. Okay? But in my triangle, I have lots of triangles that are mine. So my 45, this is 1, so I'm actually dividing everything by root 2x. So this becomes 1 over root 2. This becomes 1 over root 2. So, but since this is such a common angle, we actually rationalize this. Because it's so common. How does this rationalize? Multiply by root 2 over 2. Or root 2 over 2. Multiply by root 2, root 2. So this becomes root 2 over 2. So this really equals root 2 over 2. I just looked and I noticed that the green looks very yellow and it did not work out well. Wow, that looks terrible. Nobody made any comments as I was writing it down. Alright. So that this is going to be and then how many degrees is this one? Didn't I just do a by the way, it's pi over 3. Didn't I just do one that was like this? So by just flip-flopping the order then? So this will be 1/2, and then root 3 over 2. I'll get there. I'll get there. Don't you be worrying.
Oh, it's just like a graph.
This is a graph.
You know what I mean?
I know exactly what you mean. Okay, let's keep working around my circle. I'm going to speed it up a little bit, because here's really the meat and potatoes. Okay, well then go watch videos afterwards. Then you need to go to tutorials. If this is too fast for you, you need to go to tutorials. Here we go. So this degree amount is going to be how much? Something. 120. Anybody know the radian measure? 2 pi over 3. We're going to use the same coordinates as this, but the only difference is...
one of them's negative.
Which one's negative?
The first.
The x value, because I'm left of the origin. So this is going to be negative 1 over 2 and positive 3 over 2. How many degrees is the next one? What about how many radians is it? It's a lot. Not 2 pi over 4. 3 pi. I'll get to how you can figure this out. Some people I think are figuring it out.
Oh, I think it's 3 5.
3/5. 3/4. There's no 5s.
Someone said 3 5. I wrote it on my
Well, and then the same value from the 45 degree one over here, except first one's negative. And this last one's going to be how many degrees? 150, and what's my radians? On the bottom. Negative root 3 over 2, positive 1/2. Okay, you kind of see the pattern with my radians?
Yes, I do.
Look, across are the bottom 6. Across here, bottom is 4, and across here, bottom is 3. That's how they're all going to be. Okay? On the top, these are all less than 1. If you notice, this is 5/6 pi. This is 3/4 pi. It's 2/3 pi. So those numbers in front of pi are all less than 1. A little way to help you kind of remember. Let's come down here into, let's go ahead and do the 4th quadrant first, because we still have this as a reference. So do the 4th quadrant. So this first guy right here is going to be how many degrees? Did someone say negative 30? Because I agree with you. This is negative 30, but if I want to keep this between 0 and 360, it's going to be 330. Okay, radians. It needs to be something over 6. So something over 6. 11 pi over 6. How do you know that? What's the highest number? It can't be 12, because that'll give us 2 pi. So what's the highest number that does not go into a 6? 11 is. So this is going to be, again, it's going to be root 3 over 2 and a 1/2. Which one is negative? Why is the 1/2 negative? It's on the bottom. It's below. So the y value is going to be negative. Okay, going backwards again, this degree value is going to be 315. This is going to be something over 4. What's the highest value that's going to be of 4? That's underneath, that's below 2 pi. 7. So this is going to give me a root 2 over 2 and a root 2 over 2. Which one is negative? Isn't this so fun? This should be your entire Thanksgiving break. Oh my gosh, I agree. So fun. How many degrees is this one?
300.
300, and this one isn't over 3. What's the highest value? 5 pi. So we can get that, so it can't go over 2 pi, right? So if it's 3 is on the bottom, it's got to be less than 6. What's the highest value that's less than 6 that does not go into a 3? It's 5.
The high value of 6 that doesn't go into what?
The bottom have 2 minus 2. So what's the highest value?
I have a feeling you explained it better than I did. Alright, whatever. Now we can go into this quadrant right here. Let's start back up right here. So we're just going to go right below 180. 210. This is going to be an over 6. What number is just 7? So this trick would be, which number is just over a whole pi? Over 6. So what's the first number that's over a whole pi? So what's after 6 over 6? 7 over 6. And this one would be root 3 over 2, 1/2, but each of these are negatives. What's the next one? 225?
I'm really lost in how you're getting the degree.
So everything here, it has a reference angle of 30, 45, and then 60. So all I'm doing is I'm going from here to add 30.
Okay.
To get to this one, I have to go from here to add 45.
So you add 15.
Or you can add 15. And then to get this last one, I'm going to add how much? 60. Or 15 from there.
Oh shoot, I was just wrong.
So, by the way, so this is going to be something pi over 4. What is the 5 pi? And this last one is going to be what, Daniela? How many degrees?
Hold on. 2.
Good start.
40.
Yay! Daniela, you got it. You got it. What's the radian measure, Daniela? You can do it, Daniela. No!
It's something over 6.
Something over 3.
I can't even get that. 4 pi.
Very good.
I thought it was a long answer.
And this is the thing you have to have memorized by tomorrow. I'm just going to put a lot of pressure on you. I don't care. I don't care. Just memorize it by tomorrow. Put pressure on yourself.
Imagine. That'd be kind of clean. Like, we need to memorize, like, can we just, like,
Okay. All right, so here's my beef. I got beef. I got big beef. I got big beef. I would rather this be memorized than understood, because when you start going on a test and you don't know what sine of 5 pi over 4 is, and you're like, I gotta draw the whole unit circle. Well, how long is that gonna take you?
7 days.
I was teaching it, but it took me about 16 minutes to get this far. You're gonna waste your test on let's just say, yeah, you're twice as fast as this. 8 minutes drawing a unit circle. Don't worry, I give you ways to kind of memorize it, and then that memorization starts to turn a little bit of understanding too. Don't worry, it'll get there, okay? So you do need to have this memorized. No, tomorrow. Challenge yourself. Memorize it by tomorrow. Challenge yourself. Okay, hey, let's go back here. Let's go back here. Not on the quiz, but let's pretend it is. All right. Because my calculus students have no clue what sine of 30 degrees is, and then I just make fun of them. They have no clue, and I make fun of them. So, let me not make fun of you. What is sine of 30 degrees? Look at my triangle here. This is for my unit circle. I drew this for 30 degrees. What is sine of 30 degrees? It's opposite, which is over 1. So the answer is? So sine of 30 is 1/2. Memorize that. Don't worry, I'll help you. So, hey, let's just draw. I'm going to draw just some random triangle that's on the unit circle. Okay? Here's some random triangle. I don't know how many degrees it is, but this is going to be x and y. You agree? This makes sense? This is x and y. It's some random point. What's sine of this random theta? It's not y over x. It's y over 1, which is just?
Y.
Now y, is that important? What is sine of pi over 4? Look at the y value. Root 2 over 2. What is sine of pi over 3? Look at the y value. Root 3 over 2. What is sine of 2 pi over 3? Look at the y value. Root 3 over 2. What is sine of, I'm just picking a random one, of 4 pi over 3? Negative root 3 over 2. This is why it's important to know this. Because you need to know sine of all of these parts. You need to know every single one of them. Okay? You need to know them. I hope I'm putting a lot of pressure on you, because you teenagers need it. Easy lives you live. Easy lives. Okay. Hey, we talked about sine. Let's go talk about cosine.
Okay.
So of this triangle that's on the unit circle, what's cosine of theta equal?
X over y.
It's just x. So I can ask you anything on this unit circle. So what is cosine of 5 pi over 3? What is cosine of 5 pi over 3? It's just the x value, so it is a 1/2. Okay, we good? No. What is tangent? Tangent is going to be y over x. This one requires just a smidgen of math. I don't know. So what's tangent of 7 pi over 4? So you just divide those, and you're going to get -1. Okay, so now let's go to our quadrantals. What's sine of 0? 0, because our x value is... Sorry, y value. I don't memorize this. Just I do it differently. You are already better than me, sure. What is sine of 90 degrees in this case? Just 1. Okay, you can kind of get the idea. So let's talk about positive, negative. So you agree that in here, all of the sines and cosines are all positive? Therefore, all the tangents are positive? Okay, so this is going to be, what's positive? Sine theta, cosine theta, tangent theta. What's negative? Nothing. Let's go to the second quadrant. Which one's positive? The x's or the y's? The y's. So which one's positive? Sine. Anything else positive? No. So cosine is negative. And why is tangent negative? Because when you divide them, you're going to get a negative. I'm just sticking with just the first three. You can obviously the reciprocal, the positive number is positive. So for like cosecant, secant, cotangent, they just follow their brethren, their reciprocal brother, sister, whatever. Okay, what about third quadrant? Everything's negative. So when you divide negative over negative, what's positive? Tangent. Last one. What's positive? And on the next set of notes, I kind of go a little bit more into depth on this. So I'm just going to kind of leave it here. Okay? I don't want to give you too much. Too late for that. Too late. Way too late for that. Alright, so that, by the way, that pretty much is going to cover most of the screen sheet. So we're going to kind of skip through it. And then I will give you a last minute little bit of a hint on how I do these things. And I think I do it. I already did your video notes for when I'm not here on jury duty. So those are already done. So I know that I'm repeating a little bit. Nope. Okay, so we just did this. So using x and y, what's cosine? Just so you have it now in your green notes. What is cosine? Cosine is x. So what is secant going to be? 1 over x. Which one is sine? So what is cosecant?
1 over y.
What is tangent?
Y over x.
What is cotangent?
X over y.
Okay, so let's go ahead and evaluate our 6 trig functions. So I need to know what sine of 2 pi over 3 is. I'm going to write all these down first. I need to know what cosine of 2 pi over 3 is. I need to know what tangent of 2 pi over 3 is. I need to know what cosecant 2 pi over 3 is. I need to know what secant SEC. I'm just writing down like what really this question's asking. So it says to evaluate the 6 trig functions. So I'm just giving you all those. Like on your quiz or a test, whenever you take this, they usually could just like put this as their. They could ask for one, but I'm asking for all of them. So if you're totally lost, what could you do? Take out your handy dandy unit, circle, find 2 pi over 3.
Do we get the unit circle on our quiz?
No, you have to know how to reproduce it if need be, if you want to waste 8 minutes of your life. Or we'll get through this, you can memorize it. So what is sine of 2 pi over 3? It's root 3 over 2. Ooh. What is cosine of 2 pi over 3?
-1/2.
Ah. What is tangent. Okay, so we have to divide these, correct?
Yeah.
When you divide these, what happens to those 2's on the bottom? They cancel out. So what's root 3 divided by... I'm going to write it like this, so there's a little bit of work. So root 3 divided by negative 1 is just? Negative root 3. Ooh.
So then we just put it over 1.
Well, kind of. So these are just reciprocals. So what's the reciprocal of sine? 2 over root 3. Sometimes, if this is like multiple choice or something, like I take this answer. I'm totally cool with it. But they might ask you to rationalize it. So the answer would be multiply top and bottom by root 3. You're going to get 2 root 3 over 3. That's just rationalizing it. How did I do that? Magic. I'll show you my magical green marker here. Just multiply by top by root 3 and the bottom by root 3. What about secant? You're going to flip. You're going to get negative 2 over 1, which is just negative 2. For cotangent, you just take this guy and you flip it and it becomes negative 1 over root 3. I'll take that as an answer again. I'm cool with that. I'm just flipping tangent. Or if I rationalize this by multiplying top and bottom by, what do I get? So exciting. I couldn't wait all year. Back at HP, this is day 1. Pre-calculus. That's what we did. We did things out of order over there. Not out of, I don't know. Yeah, and I'm not a fan of their order. Alright, so this is why our unit circle is like super helpful. Okay? So let's go ahead and just go right to the back, because B is just like the same question with different radian values. So is C and D. I'm just going to just skip those because I'm going to respect your time and you should know how to do them, and they will be on the worksheet you do today. Okay, so you get a chance to practice those a little bit. So these, you already have calculators at your desk, so that's fantastic. These just say use your calculator to evaluate, so let's go do it. Just take out your handy dandy Google calculator. Alright, so if I want to evaluate sine, first off, what mode am I in? If it does not say degree, it has to be radian mode. So make sure that you're in radian mode. And look, I am. Because we're doing radians.
That looks like a real calculator.
But thank you, thank you. These are all radians except for which ones? C, E, and H. And you can always just put a degree sign afterwards if you want to figure that out. So I'm not going to do all of these again. I'm going to respect your time. I'll just do the top 4. Is that fine?
Yeah, sure.
Okay. So for the first one, I'm in radian mode. I'm going to do sine of... I use this alpha y1 enter to create my fraction.
Okay, that's
Because I'm extra, apparently. Because I get things right and I don't make boo-boos with parentheses.
He doesn't what? I don't like...
Trust me, I've been teaching long enough to know that the fraction function is very useful. I have seen it crash and burn on plenty of people. Okay? So now, since I'm in radian mode, I hit enter. And by the way, my answer should be less than 1. Why should it be less than 1? The hypotenuse is 1. Right? So this length, this is supposed to be an x value. The x value cannot be higher than the hypotenuse. And I did it. So this is equal to... How many decimals do we always round by? 3. So... 2. How in the world do you do cosecant? There's no button for that. Okay, so you're saying that if I do sine, and then... Okay, cosecant is related to sine. Not cos. Remember, there's one co per pair. So there's 2 ways to do it. You can either And you can either make your fraction like this. What a loser, it's so extra, but it's correct.
Oh, that is kind of smart.
Oh, now we're agreeing that this is a good way to do it. And hit enter, and this one should be more than 1, because it's a reciprocal. It should be more than 1. So this one's going to be 1.099. Some people don't like that rounding, so let's just go with 1.100. If you put 0.99, I'm fine with that, because I'm cool with truncating. I'm cool with it. Okay, so cotangent. You have two options here. You can either change your mode or just get smart. Which one do you want to do?
Get smart.
Get smart. So to do cotangent, how do you do that? So it's 1 over tangent of 37. That's in radians. How do you can go and hit second angle and input that degree right there, and you don't need to worry about anything. Your mode no longer matters once I do that. This is not the first time we have seen this. Second angle. So second apps, we'll pull up the angle function and hit enter. And kablamo. Do I need to go over how to find the degree again?
I got it.
So again, it's going to be second, right here, that purple. Mine's purple. I don't know what color yours is. My apps button brings up the angle options. Now, could you just go to mode and change it to degree mode and do the problem?
Yeah. Wait, what happens if it's in degree and you do that?
That's extra. That's overkill.
Okay, well,
You get the same thing.
I changed it earlier and I didn't feel like changing it back.
No, then you're good.
Okay.
Okay, so this one's going to be 1.327. Tangent of 90. By the way, we sure know tangent of 90, but we'll just let our calculator do it, and then we'll see what happens.
Yeah, I got an error for that.
What the?
You can't do 1 over 2.
Whoa, 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 whoa. An error on the calculator. Pff, that never happens. Come on. And, oh, shoot. This is why it's helpful to know unit circle. Let's go back to unit circle. What's tangent of 90 degrees? It's 1 over 0. Can you ever have that?
Nope.
So it does not exist. There's no such thing as tangent 90 degrees. DNE. It's done. Skip down here. I'm just going to do a couple of these, and I'll give you your worksheet to do, because it's probably better off for you to do it. I'll pick the ones that are kind of, like, weird. So, let's do the first one. Let's go to our unit circle and find 9 pi over 3. Someone just said I'm not going to find it. Well, I'm not going to find it. Maybe we should find a coterminal angle so it is on our unit circle. By the way, how does that reduce? Cosine of 3 pi. What's a coterminal angle that's inside of our unit circle from 3 pi? No, we're in radians. Don't say 180. Subtract by 2 pi or add 2 pi. So in this case, if I subtract 2 pi, I get cosine of... No, if I add, I get 5 pi. So it's cosine of pi. So this is equivalent to cosine of pi. I need to be inside my unit circle. So let's go to my handy dandy unit circle. And I'm at pi. And cosine is the x value. So the answer is -1. Yes. Yeah. Alright, okay, now that I know that, I don't like to do it anymore. Are we good?
Yeah, we're good. Yeah, we're good. Pass over.
We're good.
Hey, I have a question. Oh, yeah, you